last time we have started geometry of different compounds, right? Shape, hybridization, and geometry of different compounds. So
could
we have
you
discussed. Yes.
could you explain the definition of hybridization one more time?
Okay. Hybridization means mixing of orbital, right? When you make pakoda, you mix besan, onion, masala, etc. This mixing is called hybridization. Similarly, when you mix s orbital, p orbital, px, py, pz, they mix and give another orbital, another type of orbital, mixed orbital, hybridized orbital. This is called hybridization. Hybridization means mixing of orbital. When they mix, they give another hybridized orbital, different orbital. Such orbitals are called hybridized orbital.
Okay,
are you
sir.
getting my point? Okay. So we have three types of hybridization: sp, sp2, sp3. In sp3, you have px, py, pz along with s. But in sp2, you have three hybridized orbital only: s, px, py. In sp3, you have all. In sp2, you have two p orbital, px and py, and s. Similarly, in sp, you have only two hybridized orbital, s and p. This is s orbital, and this is px, py, pz. When you mixed all of them, four orbitals are formed, sp3. They are called sp3.
Yes.
Okay. When you mix again, in the double bond, always pz orbital reluctant to hybridized, reluctant to mixed. That's why hybridization is sp2. So 1, 2, 3, three hybridized orbitals are formed. Pz is remain unmixed, means unhybridized. Are you getting my point?
Yes, sir. Now I get it.
Okay, same for sp hybridization. 1s and px orbitals are mixed. Py, pz remain unhybridized. This is pz, this is py, remain unhybridized. Then we discuss shape, hybridization, and geometry. Shape, hybridization, and geometry. Now, look at again. All are, some are sp hybridized orbital, some are sp3 hybridized orbital. So this is sp orbitalized orbital. This is sp1 p2 hybridized orbital. sp1 p2 p3 hybridized. sp1 p2 p3 sp3 hybridized. sp1 p2 p3 sp3 hybridized.
Yes.
Okay. Now let's again. Question number 13. BeCl2. Can you tell me the group number of beryllium?
I think 1 or 2.
No, two.
Yes.
So it means it can form two bonds, right?
Yeah.
So again, it forms two bonds. So it means hybridization is, this is S, this is P. So hybridization is SP. Quite easy to learn how to find SP hybridized. This is called finger method. Now, you know that bond pairs are 2, lone pairs are 0. Whenever you have bond pair 2, lone pair 0, angle is 180 degree and shape is linear. Shape is linear.
So in the syllabus, we only have to know 7, right?
7 means 7.
7 of
What
these
7?
like compounds, like BF3, CH4, NH3.
Yes, yes. In the syllabus, they wrote 7 compounds, right? But in the exam, they asked different questions, right? You can
Yeah.
find all these in your exam paper, right? So they look like these 7, like 7 structures, right? That's why they can come in your exam. Now next is yes.
And sir, I had one last question, sorry, but
Yes.
it was के syllabus के अंदर लिखा हुआ था कि you have to use the VSEPR theory to explain like the structures of these.
Valence shell electron pair repulsion theory, right? We will discuss after the completion of the shape geometry and hybridization.
Oh, okay.
Okay. So question number 14. Question number 14. CCl4. CCl4. So I think carbon belongs to group 14. So it can form 4 bonds, right? So 1, 2, 3, 4. So carbon make 4 bonds. So again, hybridization is sp3. Why sp3? This is S, this is P, this is P2, this is P3. sp3 hybridized. So how many bond pair? 2. 2 or 3? Yes, how many bond pairs? Isa, how many bond pairs?
Sir, and 4.
4 bond pairs. Very good. And lone pair?
0.
0. So whenever you have 4 bond pair, 0 lone pair, shape is tetrahedral. And angle is 109.5. Angle is 109.5. Now next structure is PCl3. Next structure is PCl3 or PCl5. Now listen, phosphorus belong to group 15. It can form 5 bonds. So 1, 2, 3. 3 Cl and 2 bonds are perpendicular. So it means you have 2 angles 90 degree and 120 degree. In PCl5 you have 2 angles 90 degree which is perpendicular and 120 degree between these. So 120 degree and 90 degree. Bond pair 5 lone pair 0, two angles, 90 degree and 120 degree. And shape is trigonal bipyramid. Today is lecture number 14. Today is lecture number 14. Lecture 14. Write the first question. Write or discuss. Discuss geometry of the following. Discuss geometry of the following. First compound is CCl4. Yes, Isa, which one? Which element is central element?
Carbon.
Isa, which element in CCl4 is central atom?
Carbon.
Isa, are you listening my voice? Carbon. Carbon is the central atom. Carbon is the central atom. Carbon is the central atom. So carbon is the central atom. Sorry. Discuss geometry of the following. Discuss geometry of the following. CH4. Beta, are you listening my voice?
Yes, sir, CH4.
Beta, Isa, are you listening my voice?
Yes, sir.
Isa?
Sir, the screen share is stuck. I don't know if it's for
Jaina,
me.
are you listening my voice?
Yes, sir, I am. But
I don't know. This is lecture number 14. I'm telling again all of the lecture, right? This is lecture 14. This is lecture 14. Discuss geometry of the following. Question number 1 is CH4. Discuss geometry of the following. Oh my God. Thank you, Isam. Now, back to the point again. Electrons are negatively charged. They repel each other. So can you tell me types of repulsion? There are 3 types of repulsion. Types of repulsion. Yes, first is bond pair. Bond pair repulsion. Yes, second is. Yes, Isa, first.
Bond pair with
Yes.
Lone pair, lone pair,
Lone pair, lone pair.
and
Very
then
good.
bond pair, lone.
Okay, very good. Lone pair, lone pair. Repulsion. And then
Bond pair,
bond pair,
lone pair.
lone pair. Very good, very good. Bond pair. Lone pair repulsion. So third point is lone pair repulsion is greater than lone pair bond pair repulsion, and this one is also greater than bond pair repulsion. This theory is called valence shell electron pair repulsion theory, VSPER. Valence shell electron pair repulsion theory. This theory is called valence shell electron pair repulsion theory. This is called valence shell electron pair repulsion theory. This is called valence shell electron pair repulsion theory. Now, first question. CH4 and NH3 both have. Isa, can you tell me the hybridization of CH4 and NH3?
Sir, sp3.
sp3. Same sp3 hybridization. Same hybridization. sp3. But their angles are different. Bond angles are different. But their bond angles are different. Justify the statement. Yes, can anyone tell me why?
Sir, because NH3 also has a lone pair.
Lone pair. So lone pair repulsion is greater, right? Now look at here. This is ammonia. Here we have lone pair. So this lone pair repel this bond pair, repel this bond pair. So the angle shrink and become 107. So one lone pair has the tendency to reduce the angle by 2.5. One lone pair has the tendency to reduce the angle up to 2.5. Now listen again. Now listen again. This is CH4. This is CH4. This is NH3. Angle of CH4 is 109.5. Angle in ammonia is 107 degree. Because of the one lone pair, angle decreases by 2.5. Now, Isa, how many bond pair and lone pair in CH4?
So in what?
Yes, Isa,
CH4?
how many? Yes, CH4. How many bond pair and lone pair in CH4?
4 bond pair and 0 lone pair.
Very good. CH4 has 4 bond pairs and 0 lone pair. While ammonia has 3 bond pairs and 1 lone pair. And 1 lone pair. So CH4 has which type of repulsion? Yes, CH4 has which type of repulsion?
Bond pair with bond pair.
Oh, yes, CH4 has only bond pair repulsion. While NH3, yes, while NH3,
Bond pair with lone pair.
bond pair with lone pair. NH3 has 2 types of repulsion. Bond pair, and lone pair, bond pair. Now tell me which one is greater? Bond pair, lone pair, bond pair.
Lone pair, bond pair.
Lone pair, bond pair is greater. So the third point is lone pair, bond pair is greater than bond pair, bond pair. That's why angle decreases. This question is for 3 marks. Any question?
No, sir.
Okay, question number next. Now CH4 and H2O both have same hybridization, but their angles are different. Justify the statement. This is water. Isa, can you tell me the number of lone pairs in water?
2.
2. So how many types of repulsion in CH4 and H2O?
So in CH4, it's bond pair with bond pair. And in
Mm-hmm.
H2, it's with lone pair, and lone pair, bond pair. Bond pair. All three repulsions.
Okay. Hybridization is same. This is 109.5. So can you tell me the number of lone pairs in water?
2.
2. So one lone pair decrease the angle up to 2.5. So can you tell me the angle of water?
So 100 decrease by 5.
Yes, decrease, and then angle would be 104.5. So one lone pair di, one lone pair decrease the angle by 2.5. Two lone pair, 5 degree decreases. Now look at the answer. First point. First point. CH4 has 4 bond pairs and 0 lone pair, while water has, yes, water has. Isa, water has how
2
many
bond
bond
pair
pair?
and 2 lone pair.
2 bond pairs.
2.
Yes, and 2 bond pairs and 2 lone pairs. Water has 2 bond pairs and 2 lone pairs. So CH4 has only bond pair repulsion, and water has yes, water has how many types of repulsion?
That's 3, right?
3, exactly 3. So number 1 is bond pair bond pair. Number 2 bond pair lone pair. Third is lone pair lone pair. Third point is lone pair repulsion is greater than bond pair lone pair, which is greater than bond pair bond pair. Any question?
No.
Isa,
No.
koi question?
No, sir.
Okay. Okay, next. Now next is ईसा, मेरी आवाज आ रही है?
Yes, sir.
अच्छा, अभी तक हमने कर क्या रहा है, ये एक बार डिस्कस करते हैं फिर आगे बढ़ते हैं. हमने पहले टाइप ऑफ बॉन्डिंग पढ़ा है. सिंगल, डबल, ट्रिपल बॉन्ड सब कर लिया हमने. Now, third type of bonding. Third type of bonding is dative bonding. Dative bonding. We have discussed ionic bonding. We have discussed covalent bonding. We have discussed single covalent bonding, double covalent bonding, triple covalent bonding. Beta, do you have any question?
No, sir.
Yes, beta. Do you have any question?
There are no questions.
Okay. Now, no need to start. Still, we have more questions. Beta, next question. H2S and H2O. Both have same hybridization. But their angle and shape, but their angle is different. Explain why. Yes, give me your opinion. Yes, try to give the answer.
Sir, I'm not sure. Oxygen
Just
and
tell me.
sulfur both are in the same group.
Okay. And Raina, you?
Difference in lone pairs.
Now look at the structure. This is water. This is sulfur. Now, can you tell me the difference between H2O and sulfur? Oxygen and sulfur, both are in the same group. Both have two lone pairs. Can you tell me why the angle is different? Why shape is different?
The sulfur isn't attracting the hydrogen as much as the oxygen.
Yes, you can say that. This tendency is called electronegativity. Can anyone define what is electronegativity? Yes, what is electronegativity?
Sir, it is the power of an atom required to attract bond pair of electron towards itself.
Okay, you know phone club, DI, right? So which one is more electronegative, oxygen or sulfur?
Oxygen.
Yes. Oxygen is first point. Oxygen is more electronegative. More electronegative than sulfur. So which one has smaller bond length? Electronegativity means power to attract bond pair. So which bond pair is smaller, OH or SH?
Rho H.
OH. Point number 2, OH. Bond length is smaller than SH. So which one has more repulsion between bond pair, H2 or H2S?
H2S.
H2S has more repulsion. Which one has
I mean,
a smaller bond length? You now listen.
H2 has more repulsion.
Yes, here you have OH, here you have OH. So though both are smaller, so they come closer. These two are longer, they become far apart. So if bond length is smaller, if OH bond length is smaller, then it has more repulsion. More repulsion is 104.5. Sulfur is less electronegative. Bond length is very high, very great. Then OH. So they have long bond length, less bond pair repulsion. So if H2 angle is 104.5, so H2S angle is less than 104.5. It's between 92.5 degree. Can you find the answer? Can anyone find the answer? Bond angle of H2S? Can anyone find the... Yes?
92.1.
92.1. So 92.1, 92.5, same thing. 92.1. So OH bond length is more than SH. OH bond pair repulsion. OH and OH bond repulsion is greater than SH. More repulsion, more angle. Any question?
No, sir.
So OH bond length is shrink because of the high electronegativity of oxygen. Due to smaller bond length, OH repel.
Sir,
Yes,
do we need to memorize the bond angle for H2S?
yes. 92 point something. Okay, can I move to another question?
Yes.
Okay. Now next question is, now H2S and H2O both have same hybridization, but their angle is different. Now the next question is, NH3 and PH3 both have same hybridization, but their angle is different. Explain why. Yes.
The nitrogen is more electronegative.
Yes, same answer. Same answer. So this is NH3. This repulsion is called bond pair repulsion. And this repulsion is called Are you getting this point or not?
Yes, sir.
This is electronegative. So first point is so oxygen, nitrogen is more electronegative than phosphorus. Nitrogen is more electronegative than phosphorus. Next point. Now second point, NH bond length. NH bond length is smaller than pH. Next is NH and NH. Bond pair is greater than pH. More repulsion, more angle. Beta, are you getting my point or not?
Yes, sir. Getting.
So here you have repulsion between bond pair. Here you have lone pair bond pair. But in water, sorry, pH, this is less electronegative. So bond length is greater. So this repulsion is lesser. Less pH bond pair repulsion. Any question? Any question, beta?
No, sir.
So if the bond length is greater, it means repulsion is less. Angle is, this is 107. This is less than 107. Sometime examiner give the 105 answer, sometime 101. So it's better to write less than 107.
So, sir, we
It
don't
may
need
be
to memorize the
100.
exact value.
No. Always remember less than 107. It may be 105, it may be 104, it may be 103, but less than 107.
Okay, sir.
This is The repulsion between bond pair and lone pair. Beta, can I move forward?
Yes, sir.
Now, next question. Discuss geometry of SO2 and SO3. Just draw these two and then I will discuss. Just draw these structures in your copy and then I will discuss. Yes, can anyone tell me the answer?
Sir, I'm drawing right now.
Now listen. Sulfur belongs to group 16. So it can make 6 bonds. So 1, 2, 3, 4, 5, 6. 1 is lone pair. In SO3, 1, 2, 3, 4, 5, 6. This is SO3, this is SO2. So bond angle is, hybridization is sp2, bond angle is 120 degree. Shape is trigonal planar. And what about SO2? Yes.
P2 as well, but the bond angle will be 117.5.
Less than 107 or greater than? So can you repeat the answer? Less than 120 or greater than 120?
Less than, because of the lone pair.
So it is between 105 to 120 degree. 106 is wrong answer. 120 is wrong answer. Between 105 to 120.
Sir, won't it be 117.5? Because one lone pair, so we'll subtract 2.5.
In marking scheme, the angle is written between 105 and 120.
So if I write 117.5, will I get the mark?
No.
Oh, okay.
It's better to write the answer between 105 and 120. Okay. Next is shape. Shape is trigonal planar. It's not linear. It is trigonal planar. Now next. Discuss geometry of the following. We have discussed SO2, we have discussed SO3, we have discussed NH3, PH3, we have discussed H2, H2S. Okay. Discuss geometry of the following. We have completed SO2, SO3. I think geometry is done. Do you have any question regarding bonding? Raina, do you have any question?
No, sir.
Okay, Isa,
Yes, sir.
do you have any question?
No, sir.
Okay. Now, next topic is dative bonding. Dative bonding. Another name of dative bonding is coordinate covalent bonding. Now listen. ईसा तुम्हें मेरी आवाज आ रही है?
जी सर.
तुम बताओ मेरी कहानी सुनो. नाइट्रोजन has 5 electrons. So nitrogen can make one covalent bond with hydrogen. Am I right?
Sir, why can't it make more?
I am going to explain how the dative bond is formed, right? Nitrogen के पास 5 electron है, right? So it can make sharing. It can make covalent bond by the mutual sharing of electron with nitrogen. Now, if you have this H positive ion, so nitrogen has lone pair, hydrogen is electron deficient. They can make another type of bonding known as hydrogen bonding. Now listen again. Now listen again. You have one H positive which is electron deficient. ईसा मेरी बात सुनो. तुम्हें मेरी आवाज आ रही है?
Yes, sir.
तुम किसी पैसे वाले को भीख देते हो या गरीबों को भीख देते हो?
Sir, गरीबों का.
गरीबों को देते हो ना. तो बताओ इन दोनों में से गरीब कौन है? किसके पास इलेक्ट्रॉन नहीं है?
हाइड्रोजन.
हाइड्रोजन फकीर है. क्या नाइट्रोजन के पास एक्स्ट्रा इलेक्ट्रॉन है?
जी.
सो देयर आर 2 कंडीशन फॉर डेटिव बॉन्डिंग. जब तुम गरीबों को पैसे देते हो तो डेटिव बॉन्ड बनता है. भिखारी इज रिक्वायर्ड. ईसा सेठ इज रिक्वायर्ड. when Isa said give lone pair to Bhikari, dative bond is formed. ईसा बात समझ आ रही है?
जी.
Now look this structure again. Now nitrogen give one electron to hydrogen.